ಎಲ್ಲ PU2 ಸೈನ್ಸ್ ವಿದ್ಯಾರ್ಥಿಗಳು ನಮಸ್ಕಾರ ಸ್ಥಿತಿಗೆ ಬನ್ನಿ. ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಪ್ರಾರ್ಥನೆ ಸಲ್ಲಿಸಿ ಇಂದಿನ ಎಲ್ಲ ಅಭ್ಯಾಸಗಳನ್ನು ಏಕಾಗ್ರಚಿತ್ತದಿಂದ ಶಾಂತ ಮನಸ್ಸಿನಿಂದ ಮಾಡಿ ಮುಗಿಸುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಕಲಿತ ವಿಷಯಗಳನ್ನು ಜ್ಞಾಪಕದಲ್ಲಿಟ್ಟುಕೊಳ್ಳುವ ಶಕ್ತಿಯನ್ನು ಕೊಡಲು, ಜ್ಞಾಪಕದಲ್ಲಿರುವ ವಿಷಯಗಳನ್ನು ಪರೀಕ್ಷೆಯಲ್ಲಿ ಸರಿಯಾಗಿ ಬರೆಯುವ ಬುದ್ಧಿಶಕ್ತಿಯನ್ನು ಕೊಡಲು ಇಷ್ಟ ದೇವತೆಗೆ ಗುರು ಹಿರಿಯರಿಗೆ ಕುಲದೇವರಿಗೆ ಪ್ರಾರ್ಥನೆಯನ್ನು ಸಲ್ಲಿಸಿ. ಟೇಕ್ ಡೀಪ್ ಬ್ರೆತ್ಸ್. Yes, good morning, my dear students. So in the last class, we just introduced the IUPAC nomenclature, what is the importance of it. In detail, physical and chemical properties will be solved later in the chapter. This month, July month, we are covering 2 chapters from physical chemistry. The first chapter, solutions, will start today, and electrochemistry. 2 chapters will study today. They are numerical based chapters. Solutions. Generally, numerical based questions will be asked from the chapter, and the chapter can be classified into the first one, C1, conceptual topic 1. You can open the notebook and pen. Let us start studying introduction of the solution. Introduction. Second part is units of expressing concentration. Units of expressing concentration of a solution. Concentration of a solution. Next, you are learning about vapor pressure, and colligative properties. You study step by step colligative properties. Write the topics you want to discuss. Colligative properties. Next, you are learning ideal and non-ideal solution. Ideal and non-ideal solutions. Ideal and non-ideal solutions. And abnormal molecular weight in the same topic. Abnormal molecular weight. Van 't Hoff's factor. Okay, we'll see one by one. Just to take the heading, details I will go on giving you. We have divided the chapter into 4 topics. First of all, let us try to understand. We said that in chemistry, matter is classified into 3 types. While studying chemistry, matter is classified into 3 types. And those 3 types are element. Any substance you take in chemistry, matter is classified either into element, compounds, and mixtures. You see around you, you will get only 3 of them, mixtures. For example, if you take gold, silver, gold, iron, zinc, they are all pure elements. They are pure substances. Even compounds are also pure substances, their composition is also different. Like if you take calcium carbonate, CaCO3, if you take sulfuric acid, H2SO4, they are pure substances. They contain only one substance. Generally, elements in it are combined in a definite proportion by mass. And the mixtures are those two or more substances are mixed in any ratio is called as a mixture. What do you mean by mixture? Mixture is two or more substances, maybe element or compound, two or more substances combined in any ratio is called as a mixture. Any ratio, not a fixed ratio, is called as a mixture. So these mixtures are further classified into two more types. One is called as homogeneous mixture. What they are called as? Homogeneous mixture. Another one is called as heterogeneous mixture. See. And this homogeneous, what is the difference between them? Homogeneous and heterogeneous, we'll try to understand. Homo means the same, right? You take in a flask or any container, right? Water, dissolve salt in it and just stir it well, and you will get water. Salt solution you will get. You cannot separately see salt and water. They form one single phase. They are called as homogeneous mixture. What are homogeneous mixture? Homogeneous mixtures are when the two or components are mixed, they will form a uniform. For example, you take air. Can you separately see oxygen, carbon dioxide is present in the air, pollutants are present in the air? From your naked eyes, can you see any of the oxygen, nitrogen, carbon dioxide separately? No, because therefore air is a homogeneous mixture. Means all components will form one single phase. And for example, seawater you take. Seawater consists of large number of the dissolved salts in it, right? So this particular seawater, can you separately see sodium chloride in it, calcium chloride in it? Even in the hard water also, they will contain carbonates, bicarbonates and sulfates, chlorides will be present. You cannot see them separately, right? Such a mixture is called as homogeneous mixture. Then what is heterogeneous mixture? If instead of adding salt, you add sand to it. Sand settles at the bottom, right? You can visibly see the separation between sand and water. Therefore, sand and water, they do not make one single phase. They form different phases. Even with your bare eyes, you can see. It is a heterogeneous mixture. Hetero means different. You take oil, add oil to water. What happens to oil? Density of oil is less than water. Therefore, oil starts floating over it. In sambar, if oil is more, that oil will be floating over it. Then you say to mother, how much oil you have added? Means oil cannot mix with water. They form different phases. Then what is the meaning of homogeneous mixture? Homogeneous mixture is the mixture of two or more substances which form one single phase. Homogeneous mixture is the mixture of two or more substances. Two or more substances which have one single phase or single phase. Single phase means what? You cannot separately see the components. Components All components will be invisible. They form one single phase. You cannot separately see them with bare eyes. Even under ultra microscope, you cannot see them separately. Sodium chloride solution in water cannot be seen. For example, milk. Is it a homogeneous mixture? On the outset, you can see that milk is homogeneous. No, milk is not homogeneous. It is a fat in water, and at least under ultra microscope, you can see them separately. Therefore, milk is considered as a colloid. Colloid means heterogeneous mixture. And sand in water is called as suspension. And homogeneous mixture of two or more substances is called as our heading of the chapter. That is solutions. True solutions. There are three types of mixtures. True solutions: sodium chloride in water, ammonium chloride in water, ocean water, air. They are all homogeneous mixture. They are true solutions. What are heterogeneous mixture? Heterogeneous mixtures are the mixture of two or more substances which form different phases. Mixture of two or more substances. Mixture of two or more substances. Two or more substances which form different phases. Different phases. Hetero means different. For example, if you take colloids, in a daily life we are using colloid, your iodex, your all face creams, ice cream, dust in air. So these particular mixtures, they are colloids. Milk is a colloid. Okay. And sand in water. At least these colloids, in colloids you cannot see separately, but they can be seen at least under ultra microscope. Say if you take milk, take a glass of milk in a dark room, then you pass a beam of light through it, you will observe the Tyndall cone. That effect is called as Tyndall effect. The particles becomes at least visible under ultra microscope, and these particular solutions will, the particles, the components of the solutions will be very, very small. Even they cannot be seen in a ultra microscope. Okay. So the heterogeneous mixtures can be further classified as colloids and suspension. Mud in water is a suspension. Milk is a colloid. But these are solutions, right? We will see in this chapter about the solutions. That is a background I wanted to give you. What are solutions? Solutions can be defined as, what is a solution? Solution is a homogeneous mixture of two or more substances is called as a solution, right? A solution can be defined as, solution, homogeneous mixture of two or more components. Homogeneous mixture. Better have pen and paper whenever you study. Jotting down the points is very, very important. Homogeneous mixture of two or more substances. Two or more substances is called a solution. Homogeneous mixture of two or more substances is called as a solution. Generally, a solution will have mainly two components. What are the components? If you take salt in water, if you take air is a homogeneous mixture. You know, air is a homogeneous mixture, right? Air is a homogeneous mixture. Ocean water is a homogeneous mixture. See, what happens is, many substances are dissolved in it. Mainly, the components of a solution can be classified into two types. Components of the solution can be, there are mainly two components. One is a solvent. This is a solvent. This is generally present in a large quantity. Solvent is the component of the solution which is present in a present in a large quantity, right? For example, if you take in a beaker water, right? If you add 1 gram of sodium chloride in it, here this particular water is called as solvent because it is taken in water large quantity. You are taking 1 gram of sodium chloride, dissolve in it, shake it well with a glass rod, you will get a solution. In this, the component which is taken in small quantity is called as a solute. Generally, there are two components, solute or solutes. Sometimes a particular solution may contain many. For example, ocean water contains many components in it. Air contains sodium chloride is present in ocean water, calcium chloride is present in many carbonates, bicarbonates, chlorides, sulfates, iodides. They are all available in the ocean water. Therefore, all those components are in the small quantity. Water is present in large quantity. Therefore, in ocean water, that particular water is called as a solvent. Remaining particles of say calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate. So they are called as solute or solutes. Means a solute is a component of the solution, which is present in. Component of a solution. What is solvent? How solvent is defined? Component of a solution taken in large quantity. What is solute? The component of the solution. Taken in small quantity. Clear it to you? That is called as a solution. And generally these solutions maybe sometimes you must have seen in the laboratory. Bottles will be written, right? So you can see in one bottle which is separately placed in the laboratory and it is written as CONC, concentrated H2SO4. Generally, we are not allowed, 10th, PU7, PU2 students are not allowed in the beginning to use the concentrated sulfuric acid because it is highly dangerous chemical, kick-off chemical, highly corrosive. Generally, the bottle kept at your tray so that you can use it will be written as dilute sulfuric acid. What is the difference of concentrated and dilute? Solutions are classified. Let us start the classification of the solids, that is solutions. Basically, in the laboratory, you will get two types of bottles, concentrated hydrochloric acid, concentrated sulfuric acid, dilute sulfuric acid, dilute hydrochloric acid, like this. Okay. And dilute means a small quantity, right? Small quantity of a solute, small quantity of the solute is dissolved in large excess of water, large excess of solvent. If the solvent is water, then the solution is said to be aqueous solution. Generally, if the organic solvent is there, alcohol is the organic solvent, that is a alcoholic solution. Means what? Generally, solutions are determined by, not by solute, but by solvent. Right? Solvent will determine the state of the solution. Generally, if you take sodium chloride in water, right? That sodium chloride in water, if you see, it is in liquid state, right? Because the solvent water is in liquid state. Generally, physical state of the solution is determined by solvent but not solute. If you take air consists of in the gaseous state. All other components will be present in it, but physical state of the air is gaseous state. That is, depending on that we can classify. First step you understand in the laboratory, small quantity of solute is dissolved in large excess of solvent, then we say that dilute. Right? And similarly, concentrated sulfuric acid, if you take, means large quantity of large or maximum quantity of maximum amount, that is maximum amount of solute is dissolved in maximum amount of solute is dissolved in fixed volume of solvent, fixed volume of solution, sorry, fixed volume of solvent, right? In a beaker you take, okay, some 20 cc of water, 20 to 30 cc of water, right? You go on adding sodium chloride to it. Sodium chloride, 1 spoon you add with a glass rod, you shake it well. Again add another spoon, go on shaking it well, right? And it will dissolve. Every solvent will have a capacity to dissolve certain fixed amount of the solute. Here solute is a sodium chloride, water is a solvent, right? And you go on dissolving sodium chloride in it, and a stage is reached when it cannot dissolve at a given temperature, at given room temperature. You cannot, the solute cannot dissolve, the solvent cannot dissolve any more solute in it, then you can expect, even though you shake it well, the sodium chloride will settle at the bottom. Then we say that the solution is based on the amount of the solute that can be dissolved in it into two types of solution. About that we will be studying later. One is called as saturated solution. What it is called as? Saturated solution. Andrenu, what do you mean by saturated? Means tripta. Suppose that your capacity is to eat what? 5 idlis is your capacity of eating. After eating 5 idlis, what you say? You say, no, my capacity is over. I cannot eat any more idlis. Means your stomach has reached the saturation. Similarly, every solvent at a given temperature will have capacity to dissolve certain fixed quantity of the solute. Once its capacity is over, it cannot dissolve anymore. Even if you shake it well, anything, then it is called as saturated solution. We are going for classification of the solution. Depending upon the quantity of the solute and solvent, we can define as dilute solution, concentrated solution. Further, depending upon the capacity to dissolve a solute in it, they can be further classified into saturated solution and unsaturated solution. What do you mean by unsaturated solution? Saturated solution can be defined as a solution which cannot dissolve any more solute in it under given temperature. Very important. Because as the temperature increases, suppose that it is not dissolving, then what do you do? Start heating it. As the temperature increases, solubility also increases. And more amount can be dissolved in it. And what is unsaturated solution? At a given temperature, if a solvent dissolves more solute in it, not at reached the saturation, right? A particular solution, before attaining saturation, you added 1 spoon of or say 10 gram of sodium chloride, it will dissolve. Add 20 gram of sodium chloride, it will dissolve. Means before attainment of the saturation, then at a given temperature, then the solution is said to be unsaturated solution. Thus we studied two types of solutions basically, that is a dilute solution, concentrated solution. saturated solution and unsaturated solution, right? Even there is a super saturated solution also. If the crystals will settle down, even excess of crystals will settle down, then it is called as super saturated solution. Like this, solutions can be classified on the basis of the solute and the solvent, depending upon the physical state of the solute and solvent. We can further classify these solutions into 9 types, right? So that we will study first. See, depending upon the physical state of the solution, solvent. Let me write here, if I take the solute may be solid, may be liquid, or may be gas. If the solvent is fixed, say if the solvent is gas, then when solid in gas is one type of solution, liquid in gas in one type of solution, gas in gas is another type of the solution, right? And the solvent will decide the physical state of the matter. Means solid gas solution, liquid gas solution, and gas solution, and such solutions are called as gaseous solutions, or they are called as gaseous solutions. Why they are gaseous solution? I told you that generally physical state of the solvent will decide the state of the solution. Now, as a solvent is gas, if you take solvent is gas, then it is called as gaseous solution. Some examples of the gaseous solutions you can take, right? Gas in gas, gas in solid, right? Okay. Dust or smoke in air. You can take examples, some examples of solid in gas. First type, solid in gas, gaseous solution. Liquid in gas, liquid in gas, liquid in gas. Gas in gas, gas in gas. First one will be solute, second one will be solvent. You can give examples to them. Can you give examples of solid in gas? You can give the examples of dust in air, dust or smoke in air. Smoke in air is example of solid in gas. You can take camphor in nitrogen. Camphor in nitrogen. Nitrogen is an example of gaseous solution. And even you can take a liquid in gas. Can you give example of liquid in gas? Liquid in gas, water vapors. Okay, chloroform mixed with nitrogen, water vapors in air. Chloroform. What is the formula of chloroform? CHCl3, actually used as anesthetic. Chloroform mixed with nitrogen. Nitrogen is an example of liquid dissolved in gas. You can take moisture, mist in air, water vapors in air, which cause humidity, water vapors in air. Then gas in gas. Best example is mixture of oxygen and nitrogen in the air, right? Mixture of oxygen. Air is a gas in gas mixture. Oxygen with nitrogen and oxygen is mixed, present in the air with carbon dioxide. With the carbon dioxide is a gas. So these are gaseous solutions. Third type of the solutions. That is, depending upon the physical state of the solute and the solvent, we can classify them into 9 types. Solid in gas, liquid in gas, gas in gas. Right? This is called as gaseous solution because solvent has the state water, solvent has the state, which state? Solvent is in gaseous state. Therefore, generally solvent will decide the concentration of the solution. This is first set of solutions. If I change the solvent into, instead of gas, I will take a solid, liquid. If the solvent is liquid like water, then again we will see solid, liquid, then gas. Solid in liquid is one type, liquid in liquid is another type, gas in liquid. Can you give examples for it? 3 types of solutions are possible and the state will be what? Liquid state. For example, just now we studied sodium chloride in water. Any salt, most of the salts, ionic salts are soluble in water. That is, salt in water, ammonium chloride in water. You take any ionic compound that is soluble in water because ionic compounds are ionic. Water is also polar. Sodium chloride is polar, water is polar. Polar dissolve in polar and form a solution. Solid in liquid. Clear? Liquid in liquid. You can take example of solid in liquid. First example, sodium chloride in water. Liquid in liquid, you can take example of ethanol. Ethanol, alcohol, people drink, no? Ethanol, C2H5OH. Even though it is organic compound, it is soluble in water. Ethanol in water is a solution of liquid in liquid. Right? And generally, gas in liquid. You know, soda water. Soda water, generally you drink soda water, no? Soda water, right? What is soda water? Soda water will contain water. Carbon dioxide gas is dissolved in water, right? So, carbon dioxide gas is dissolved in water. Later we will talk about it. Carbon dioxide in water is called as soda water. Generally, the moment you open it, it will rush out with bubbles. Because it is stored under high pressure. Once the pressure is released, carbon dioxide gas will come out. Carbon dioxide in water is an example of gas in liquid. Even aquatic animals. Oxygen in water. How the aquatic animals will get oxygen? Aquatic animals will get oxygen at a given temperature. Water will have ability to dissolve some oxygen in it. Aquatic animals will survive by using that oxygen. This is second classification. Solid in liquid, you can take a sodium chloride or sugar in water. Sugar in water. Liquid in liquid, you can take ethanol in water. Right? So many solvents are soluble in water. Hydrochloric acid in water, dilute. Sulfuric acid in water, dilute sulfuric acid is a mixture of water and sulfuric acid. Like that, liquid solutions are available. Gas in liquid, carbon dioxide in water, oxygen in water are the examples of liquid solutions. They are called as liquid solutions. Liquid solutions. They are called as liquid solutions. Third one we take, this time we studied gaseous solutions, then liquid solutions. Last one is solid solutions. We'll see solid solutions also. Okay. Solid solutions means they will be in the solid state. Some examples of the solid solutions we'll take now. This time I will keep the solvent as solid. Try to understand. Again we will take what? Liquid or solid, liquid and gas. You can take solid in solid, liquid in solid, gas in solid. Right? Can you give examples for it? Solid solutions. Solid in solid. Most of the alloys. You can take examples of them. solid in solid. You can take example for this one, solid in solid. Example will be all alloys. What are alloys? Alloys are nothing but a homogeneous mixture. We define alloys as homogeneous mixtures, mainly homogeneous mixture of two or more mixture of two or more homogeneous mixture of two or more metals and metals, mainly metals and metals. You can take example of brass. You can take example of bronze. You can take example of stainless steel. What is the physical state of them? Brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. And stainless steel you are using in your kitchen, white colored, it consists of iron, carbon, nickel and chromium. Means it is a homogeneous mixture of different solids. Most of the alloys are solid in solid solutions. Then liquid in solid. Can you give examples of liquid in solid? Generally, there are some alloys called as amalgams. What are amalgams? Have the note of it, amalgams. Any alloy of metal, remember this one, any alloy of metal, have a note of it, any alloy of metal with mercury, Hg. You know that only liquid metal is mercury. You remember, most of the metals exist in solid state except mercury. Mercury is in the liquid state. Therefore, liquid in solid. See, when you mix sodium is dissolved in mercury, we call them as sodium amalgam. Any alloy, sodium amalgam. When you mix zinc with mercury, called as zinc amalgam. Remember this word, amalgam. Generally, amalgam means solid in liquid example. Then gas in solid. Yes. What are the examples of gas in solid? Generally, gas, hydrogen gas can be absorbed on. Suppose that this is a liquid. Either you can take nickel, platinum, palladium, you can take. When you pass hydrogen gas over it, right, this hydrogen gas will be adsorbed on it. This is not absorption, remember. Adsorbed means hydrogen gas will be adsorbed on the solid, and this adsorption means it will be held only on the surface. Absorption means it will go enter into it. Try to understand the difference between absorption and adsorption. Later in chemistry we will be learning. Absorption means sponge in water. You take sponge and dip it in water. The water molecules will completely enter into the all parts of the bulk of that sponge. That is called as absorption. Clear to you? This particular hydrogen gas on the surface of nickel, platinum, palladium will be adhered only on the surface. That is called as adsorption. Right? Then you must have seen charcoal. Charcoal will have small pieces over it. Right? So this can absorb different gases through the holes. That is called as absorption. Right? Means gases can be adsorbed on the solid surface. Right? So these are the classification of different types of the classification of the solutions. Solutions can be classified as we made 3 types of solutions based on first one we studied is that solutions, that is a dilute solution, aqueous, that is concentrated solution. Then we studied saturated solution, unsaturated solution. 9 type of the solutions depending upon the physical state of the solute and the solvent, and the respective examples we studied. I hope you understood all these things. Let us come to the second part of it, that is concentration of the solution. Units of expressing. Very, very important numericals. Units of expressing. Concentration of a solution. What do you mean by concentration? We'll try to understand. Concentration of a solution. Now the question is, what is concentration? Means that suppose that observe here, like concentrated and dilute, I told you, no. Suppose that this is a container containing a particular substance. If the number of solute particles are very few, here if the number of solute particles are highly concentrated, means what is the difference between, suppose that in this particular container solvent is filled, here you observe it is less concentrated. We can say that it is more concentrated. Means what do you mean by concentration? Concentration means amount of the substance, the amount of the solute dissolved in a given one of a solution is called as concentration. Concentration means amount of the substance of the substance dissolved in, right, given volume of the solvent, This concentration, very, very important concept to start the numericals, even in stoichiometry also. This is a stoichiometric part of it. Okay. These particular solvents can be expressed. This concentration means if the amount of the substance in a given one solution is more, then we say that it is more concentrated qualitatively. If the amount of the solute in a given volume of a solution is less, then we say that qualitatively less concentrated. Now, is it possible to measure concentration quantitatively? Quantitatively means exact amount. Quantitatively, yes, we can express the concentration of the solution quantitatively by using proper units. These units of expressing concentration, there are different units of expressing concentration of a solution. We are using them throughout the syllabus. Therefore, in the first phase, you have to understand what are the different units of expressing concentration quantitatively. So those units I will list out. The first one is mass percentage. Mass percentage. You can write it as a W bar W. Second one is mass volume percentage. Mass volume percentage. You can write it as a W bar V in short. Third one is volume concentration. Volume percentage. That is V by V. Okay. And the fourth one is molarity. Very important. Molarity. Capital M we write it as. Fifth one is molality. Molality. Small m. and the sixth one is mole fraction. These are some of the units we are using to measure mole fraction. Throughout the solution chapter, this is important. These particular units and their conversions is very, very important. Numerical area. Seventh one is called as ppm, parts per million. ppm, you can say parts per million. Parts per million. That is ppm. I hope you understood. Clear? Okay. So what are these units? How they can be numericals on it? Be ready for the next class, right? Today, because to start them, we have to start numericals. This was the introduction part of it I wanted to introduce. And next video, be ready with notebook and pen to calculate. Number of level of questions are there. First of all, I will clear you numerical part of very, very important for competitive exams. Conversions problems will be asked in the exam. Okay. I expect more of you to come on live stream and learn the things. Okay. And I invite all of you to Lokji channel. It is not only a channel, it is an institution. Right. And download Vedims app. In that you can improve your mind maths just by paying 540. Okay. And after this class, Saturday, Sunday, 2 days, I will be out of station. Directly we will meet on Monday to continue the study of units of concentration of the solution. Till then, sleep well, read well, keep your mind and body cool, do exercise, do prayer, take blessings from your parents, blessings from your Guruji. All the best, my dear students. Continue in the next class. Till then, bye-bye. See you.